Ping pong players are getting more skillful every day. Eventually, we will see ping pong balls breaking the sound barrier. As a result, Team 3 has decided to design a supersonic ping pong battle. In order to play a fair game, a ping pong battle must be created that can not only withstand the impact of the strike, but also return the ball without breaking. This includes no plastic deformation or delamination while also keeping the paddle similar size to paddles today.
So for our design method, we first need to derive the expected forces that the paddle would endure. In this case, it's from the supersonic ping pong ball. We then selected a material to construct our paddle of, and then we need to determine the laminate characteristics. So you can see those details on the slide right here. And in order to simulate all of this, we used SolidWorks, which created a mesh on the object to simulate the stress, strains, and how the object deformed. So we tried to keep the object as simple as possible, so that way the program didn't have to work too hard, so areas such as the handle are kept relatively simple. And you can see the two strains that resulted for two separate simulation just examples here on the right.
For our design, we settled on using a Kevlar 49 epoxy laminate instead of a UHMW polyethylene due to the lower cost and readily available knowledge of Kevlar's properties. We chose a composite over traditional metals because of the strength-to-weight ratio, keeping the paddles easy handling. The SolidWorks simulation showed our minimum thickness needed to survive the impact was 0.6 inches, assuming an individual pre-preg layer thickness of 13 thousandths of an inch. We would need 46 layers in total. We also decided to use a cross-ply symmetric layup for simplicity and to remove any bending couplings. Here we also list the maximum strain and stress the material can withstand.
To produce our paddle, we will be using a vacuum-assisted resin transfer molding process with a 2-piece mold. This will ensure a high-quality composite with smooth paddle faces. The Kevlar layers will be stacked dry, inserted into the mold, and the resin will be pulled through by the vacuum. Since the resin can emit toxic fumes, proper safety equipment must be worn throughout the process.
We will be performing tests for fiber and matrix characterization, interface properties, and coefficient of thermal expansion for a lamina. To find the elastic properties and strength parameters, we will perform longitudinal tension, transverse tension, longitudinal compression, transverse compression, in-plane shear, interlaminar shear strength, interlaminar fracture toughness, interlaminar fracture biaxial loading in stress concentration tests.